Okay, the packet comes over here and then goes to over bus A, okay, and then since it is a 10 meg, it's going to go basically here, okay, because this is a 10 meg ASIC, okay, make here and comes over here through the interrepeater backplane, okay, and comes over here to this quad and then goes out. You see, this 10 meg is being processed by which ASIC? By this one. Why this one? Because when a frame was being learned on this port, went through this path, comes over here, 10 here, ASIC here, goes to lookup table. Okay, so basically the frame was learned on port what? On ASIC 2. See, so that's the way, for example, the switching takes place, because it goes through different ASICs, you know, goes to the bus and the switching takes place. Now, in terms of what you were saying, is this one. Now, say that we have here 100 meg link. Okay, we are going across two groups. So you have a connection to group 1 and you have a connection to group 4. Okay, it means you're putting one link here and one link here. Let's see what is the scenario here. The packet comes over here, okay, goes here, he knows has to go to this one after learning. Okay, travels the bus A, goes to here, and this is 100 meg, so therefore this ASIC is going to take care of it. Okay, odd ASIC takes care of the 100 meg link, and even ASIC takes care of 10 meg link. Okay, comes over here, and through the 100 meg link is going to go to this link. And if you have a link here, you are going to receive it. If you have a link here, you are going to receive it. Okay, these are if you have a link here. And also since it goes here, and if you have a link here, also you are going to receive it. Okay, since you have a 100 link, how many you are going to have node or port to receive it? 1, 2, 3, 4, 5, 6, 7, and we have port here 11, 12, 13, 14. You see? Or for example, when you look at here, this is a simplified version of it. Okay, so you have a 10 meg here and 10 meg here. And look at how fast the packet is going to go. This packet is not going to go over the bus. The only time it's going to go over the bus is for the learning purpose. Okay, but here the packet goes here. Okay, and when the packet goes here through the ASIC number 2 is going to be learned. Okay, this packet also goes here through ASIC 3 is going to be learned. So both of them are learned on the what? On port 2. Okay, so when the packet comes, this one is going to drop it. But however, this quad through the backplane is going to what? It's going to forward it because it's a hop. You see? And say 3, 4, 5, 6, 7 users are going to use it. Or you can have, for example, 100 meg here, okay, and address the 100 meg to the 10 meg. Is going to switch from this group to this one. So everybody on this group who is having a 10 meg link is going to receive the frame. Why? Because the destination for this packet is here, so it's going to go here. Yeah. So what this 2048 is doing is integrating the hop as well as switching for a work group workstation. Then you have a expansion slot here. You can put the gigabit. If you have a 10 meg link, you don't need a higher backbone. Okay, you can put a 2012R. And if you're having a lot of 100, then you put it in a gigaframe switch. Gigabit. Yeah, the VLAN is an interesting subject. It's a little bit confused. You have to know exactly what is the VLAN and the switching, what layer it is,
Okay, my presentation is about the Gigahub. Okay. The Gigahub is aimed to give a full solution for the network manager for any needs that he might have for the network, ranging from Ethernet 10 base, 100 base, gigabit connection to ATM or FDDI. And you can use switching and repeaters, cards that go into these machines. We also support token ring, FDDI, and power and point-to-point protocols, real-time protocols for IBM environment. So the Gigahub comes in two types of models. One is a 12 ports, this one, okay, 12 ports, 12 slots, and the other one, its smaller brother, is 4 slots. The bigger machine, you can put up to 4 power supplies, and the fourth power supply is always work as redundant. So actually 3 power supplies are working and the fourth is redundant. In the other machine, you can put up to 2 power supplies and they work together. All the cards in the system are hot swappable. That means that you can insert a card or remove it without malfunctioning any operation in the system. Also, the circuit has over-limit current protection. So if there is a short in the card for some reason, then this circuit will shut down the power to the card and thus prevent it from burning or actually stopping the operation of the whole system. These two systems has LCD and push key buttons above. You can see it here. So the user can locally put commands or look at monitoring indication through this LCD. You can give basic commands like attach or detach port, select ports to be 10 or 100 base, full or half duplex. You can monitor any errors in the system. You can even put an IP address for some of the cards. And you can also connect or disconnect cards into the backplane. So you actually make the configuration of the whole system. You can do it through the LCD. We also have FDDI and ATM modules that goes into this this machine, and the gigabit, of course. And another thing is that with this type of chassis, and mainly the bigger one, we also support all the real-time protocols that were all real-time protocol cards that were done for its predecessor called the multi-hub. Before the Gigahub, we had another chassis called the multi-hub, and it was a very successful product. But when we moved to this to the Gigahub in order to support the new LAN cards, we also wanted to have the option to use this Gigahub for these cards. So what we are doing is we're putting in order to use these old cards, we put a special adapter into the system, and those cards are stacked into this special adapter because the multi-hub was a little bit smaller than the Gigahub. Okay. So an obvious question is to ask why choosing the Gigahub? Other companies have also multi-slot products, and why is this Gigahub is better than others? And the answer for this is that the powerful of the Gigahub is residing in the architecture of the backplane, because the backplane is what is doing the Gigahub. It makes the power of the Gigahub. And the backplane is totally passive. There is no active components on the backplane. We are using to call this backplane a matrix bus. because the way that the backplane was designed is to use it as a matrix bus rather than a simple bus, rather a simple parallel bus. And when we designed it 4.5 years ago, we knew two things. One is that in the future there will be high-speed buses, high-speed protocols, because FDDI was already there, but we anticipated there will be more high-speed protocols. And the next thing was that at this point of time, we didn't know anything about how the other protocols will behave like. And so we want to support all kinds of topologies that might evolve in the future. So we have come with these solutions, and there are two basic concepts in the design of the backplane. One is that the matrix bus is designed to carry very high speed signals. And when I say very high speed signals, I mean that we have there 40 high speed transmission lines. Each transmission line is actually dual line, so it's dual-ended. And every one of them can carry high-speed signals, which can go up to 400 megabits per second each transmission line. So you can have totally up to 16 gigabits per second of bandwidth over this backplane. And you can, of course, ask how do you do it? Because it's 400 megabits per second transmission line. It's really something very unique. So I would say that this backplane was designed with AMP. You probably know about AMP. It's the biggest, I think, supplier of connectors. They have specific division in France that design backplanes. So the design of the backplane was done together with them. We said what kind of architecture we want, which was the matrix bus. And with them we designed the backplane so it will withstand these requirements. So all the signals have 50 ohm impedance. They are very carefully designed so the crosstalk will be minimal. I think it's better than minus 20 dB. The termination, the connectors, the receiver and transmitter into the backplane, everything was taken into account. Everything was simulated, was carefully simulated, taking into account thermal conditions and variation in the manufacturing of the backplane. And it was proved to run up to 400 megabits per second. And even after the production, we also tested for these high-speed signals. So actually, we can carry a 16 gigabit per second of bandwidth over this backplane. So this is one major concept of the matrix bus. And the other concept of the matrix bus is what we call here a generic network architecture. And by this we mean that when we are running a protocol over the backplane, we are actually running the protocol as is. And what I mean is that when we are running, for example, an FDDI switching, we're actually running the FDDI over the backplanes. We are actually creating a ring topology in the backplane. And so it's for token rings. When we're saying that we are having, we can have up to 12 rings of token rings in the system. You can up to 12 token ring LANs. And each LAN can have its own ring over the backplane. So you're actually running a token ring there. And for the 100-based Ethernet, it's the same. We're actually running a 100-based Ethernet on the backplane. And the nice thing about the matrix bus is that you can run different protocols at the same time on the backplane. So you can have an Ethernet switching, a 100-based Ethernet switching machine running on the backplane, and other cards can run token ring or run FDDI or anything else. They do not interfere with one another. Another nice thing about the matrix bus is that because we run in the native topology, we do not need to make any translation from the protocol into some proprietary media. We don't have to translate it into a parallel bus and retranslate it again, and to take into account all kind of parameters that the protocol might need and you must be required to withstand. We run it as is, so if we are actually complying with the standard, then everything will work. So this is a nice thing about the matrix bus. And the other thing that is mentioned here is that for token ring and FDDI, it is very important that if one of the cards that is participating in the ring fails, that it will not degrade the performance of the whole ring, because then the whole LAN will fail. So the system has an automatically recovery from such situations. In case of malfunctioning of one of the cards, the ring is shutting or skipping this card, and when it recovers, it brings it back into the ring. So actually, this is the essence of the Gigahub. So we were talking about the matrix bus, which support the fast Ethernet switching cards. These are the cards that we have today. It supports the FDDI to Ethernet switching cards. This was the predecessor for the cards that we have today. And it also supports FDDI to ATM switch cards that we have. It also supports the FDDI distribution cards. I will show you to you later. And the token ring distribution cards. Now we're running the token ring distribution here also. Though they can only get up to 16 megabit per second, we run it also on the matrix bus, which is actually was designed for high-speed signals, because of the way that we can do rings over the backend. Besides the matrix bus, we have an additional bus called the Ethernet buses. We have there up to 8 10-base Ethernet buses, and they are mainly for the Ethernet distributions cards. And when I say Ethernet distribution cards, I mean the Ethernet repeater cards. So actually you can tie several, 2 or more Ethernet distribution cards on these special buses, and then you can get a bigger repeater. I will come to this point later. I'll just mention that we have here up to 8 10-base Ethernet buses. We can also use these buses for the fast Ethernet distribution cards. We also have 100-base repeater cards, and they can also use this bus. The TDM bus is not part of the backplane itself. It's another backplane. It's another board. It is part of the mechanical adapters that I was talking about before when I said that all the multibus, the Unimux cards, like those of the IBM 3270, AS400, T1M1, RS232, and the IBM card, the 5080. All these cards are going into this TDM bus, and this is a separate bus. So I will first I would like to concentrate on the Ethernet switching system, because I think this is the major functionality that we give into the Gigahub, and I think it shows as the most powerful of the Gigahub. A classical configuration of the Gigahub is to have one powerful switching card with a lot of 10100 base ports, and this powerful card is connected internally into the matrix bus to other switching, to additional switching cards. In this drawing, these switching cards have a lot of 10 base ports and a few 10100 base ports. So actually we have a switching machine in every one of these cards, and a powerful switching machine in the central card. So this working group switch, because it's a lot of 10 base going to the user, and the 100 you can use to tie it to a server. So this working group will switch between the local users, and the other, all the other packets that's supposed to go to other ports will go via this main switching card. Okay? This central switching machine also housed the high-speed modules as the gigabit Ethernet, the ATM, and the FTDI. Here's another drawing that shows how the connection is done internally into the matrix bus. You see, for example, here the main central switching card. This example is 598, and it is connected internally via several 10100 base ports into two additional cards, which are also 10 base switching card, and you can see it here. So every port is connected to one of these cards, and you can have, and this is a way that you can actually get a bigger machine. Here is another example. In this example, we tie the fast Ethernet repeater cards to the main central switching card. You can see that this fast Ethernet distribution card, called LC3722, put one of its ports into the matrix, and through the matrix is connected into one of the ports of this switching, and this is the way that the switches are, the repeater are connected through this switch. In this switching system, this Ethernet switching system, we have three families of cards. The first one of them is XM542, which gives 16 ports of 10 base, all of them are switching, of course, and 2 ports of 10100 base. One of the ports is permanently 10100 base TX, and the second 10100 base port can be connected either externally to a module, which can be a 100 base FX, or it can go internally to be connected to the central switching card. You can see also here some of the features of this card, like address table of 8K max, buffer space of 8 megabytes, aggregate throughput up to half gigabit per second. Of course, every one of the ports can be half full duplex, port mirroring, SNMP, spanning tree, and auto polarity detection. Here is a block diagram of the switch. There is an ASIC, a group of 8 10 base T ports. 10 base T ports, and one ASIC per the 10100 base ports. And you also can see that one of the ports can be either selected to go outside, externally to the network, or to go internally to be connected to the matrix bus and through it to the central switching machine. Also, there is an option to connect up to 4 of the 10 base ports into the special Ethernet buses. You remember that I talked before that we have 8 10 base Ethernet buses. So you can connect here up to 4 ports, and thus connect the 10 base repeater cards to the switching machine. Here's how the card looks like, and I put it here just to show an example of one of the cards of the Gigahub. You have, in this example, you have 2 LEDs per port for a link and for a receive. You have the 16 ports RJ45 for the 10 base, and one connector for the 10100 base, and here is a space for the module, for the fiber optic module. This was one family. Another family called XM580X, also switching cards. But in this family we have all the ports are 10 and 100. And you can have here several options, and you will choose it according to the needs of the system and the network. For example, if you need to tie this card and operate it as a central machine, and you want to connect to it several cards, you can use this one, XM584, which have 6 steerable ports of 10^6. And when I mean steerable, I mean that 6 of the ports can be directed either outside to the external network or internal into the matrix bus. If on the other hand you want to use a card to connect to a remote Gigahub, and for a remote site you may use 100-base-FX. The remote site can be another floor or another building. You can use maybe this one, the one with a 1200-base-FX, or the other one that has only 600-base-FX. That depends on your needs. There is also a possibility to begin to just begin a new network when you are just assembling a new network. Use a smaller card that have 10 ports fast Ethernet, with 2 of them going into the system and all the others going externally. 2 of them are 100-base-FX. And the features, as for the switching, the features are more or less as the features that I talked before. 8K MAC address table, 8 megabyte buffer space, aggregate throughput is bigger, and we have here the port mirroring, the SNMP, Harmon, and half and full duplex. The third family is called XM590X, and this is the most powerful switching machine that we have. It is based on the technology of the MegaSwitch 2. So actually we are using what we have in-house to build better machines. So we use it here, and again you can have here several options, and that depends on the needs of your system. If you need to tie this card into a lot of additional cards, you can use either this card, the 598, which has up to 8 ports going into the matrix bus, or you can use the other one that also has up to 8 port fast Ethernet going internally. The difference between this one and this one is that this one is a dual, takes dual slots, 2 slots. And the reason for it is that we have more external ports going outside. Here it's a 1 slot only, but then you pay by the 4 of the 100-base ports are going permanently into the matrix bus. So actually we save the panel area, and thus we get 1 slot instead of 2 slots. And again, if you need to have a lot of fiber optics, you can also use this one, which has 600-base-FX ports. Or if you're just or if you're just assembling a new network and you don't need so many fast Ethernet ports, you can begin with this card, the 594, which have 4 ports Ethernet switching ports plus 1 modular link. By the way, all of these cards have a modular uplink, which can be gigabit, ATM, FTDI. And as I said, since this technology is based on the MegaSwitch 2, you have all the features that you have in the MegaSwitch 2, you also have here. Here in the following 3 slides, I show briefly the architecture of the cards. For the basic cards, the 594, where we have 4 10100 base ports, you can see that here are the 4 ports can be selected to go externally to the external network or internally into the matrix bus. and the space for the expansion module. In the XM, it was 598, 594. You have basically the same motherboard, but you can plug in another adapter that gives an additional 4 ports that goes permanently into the matrix bus. And the 598, which gives you additional 4 ports going externally or internally, and an expansion slot for an uplink module. These are the modules that we have. Actually, they are the modules that we have for the MegaSwitch 2, for 2 ports of 100 base TX, 2 ports of 100 base FX for multimodal single mode, VLAN expansion module, ATM, the gigabit, and the FDDI. Here is the features, but more or less we cover them more or less. And again, this slide shows you again the connection into the matrix bus. In this example, we tied one of the 542 switching cards, which have a lot of 10 base and 2 10-100, to the repeater cards via 4 of the Ethernet buses. Each of the repeater card is connected to one of the EB2, which is one of the buses. And you can also make a bigger repeater by tying 2 of the cards through another bus called a synchronous Ethernet bus. So this is how we connect the repeater cards into the switching machine. Here again, you see how we tie several switching cards. I showed it schematically before. You have the central switching card connected internally into the matrix bus to other switching cards. Okay, so I covered till now the Gigahub switching system, and now I'm going to show you the other cards that we have in the Gigahub. Okay. There is something that I want to say before we proceed with the Gigahub, with something that is related to the switching. What I cover now is the actual cards, the most current and newest cards that we have now. We also have a predecessor generation of the switching cards. There is a card, I will just mention it so you will know, when you meet it, you will know what to expect, what does it mean. One card was done about in 94. It's called XM516. It's a switching card that have only 10 base ports. It has up to 6 ports, and we use it to switch between the repeater cards. Okay. Actually, there are XM516 and XM517. The 516 is 6-port 10 base TX, 10 base T, and the 7 is with modular ports. So you can have up to 8 modular ports with, actually up to 15 modular ports with 10 base T, 10 base XL, 10 base 2, all the media that you have. So this was the first generation. The second generation is a family called XM530X. This is an FDDI to Ethernet switching card. The Ethernet is mainly 10 base T, and we can have up to 20 ports of 10 base T. We can have up to 2 ports of FDDI, so it's switching between them. You can replace one of the FDDI to 100 base TX, but basically it's 10 base T switching card. Our recommendation is, of course, to use the newest cards because you get much better performance. The throughput is much bigger because here it's actually the FDDI. you get much better performance. You have much more 10 and 100 base ports. But there is one advantage of these cards is that if you have an extensive use of FDDI, a site that have extensive use of FDDI, this might be a good solution because you have these two ports of the FDDI. You can also tie to it all our FDDI repeater cards, so you can have a very nice FDDI system with these cards. But for Ethernet, for ATM, we prefer those cards. So this was just a remark, and I will go back to the presentation. Another family of the Gigahub is the repeater cards. This is a 10-base repeater cards, and you have here a lot of options. You have here a 12 ports of 10-base T. You have 8 ports with modular ports, so you can put 10-base 2. You can put 10-base FL. You can put 10-base 5. So there are a lot of options here. You have a card that has 36 ports. This is a mistake. Here are 36 ports, and the 344 is 24 ports. I think that the reason they put here the 3 and the 2, the person that was doing this slide actually meant that there was supposed to be here, I think, a column that said how many segments. So all of these repeater cards are actually one segment, okay? For the 36 ports, you can have up to 3 segments. That means that you can take this 36... So you can take these 36 ports and configure them in such a way that you have 3 separate 10-base segments, and then you tie each of these 3 segments or ports into the switching machine. And the same goes for the 24, where you can have 2 segments. Okay? And another card that we have, another interesting card that we have here is a security card. That means that the repeater card is working in a mode of security, which means that it transfers the data only to the destination port, and all the other ports get jammed data. This is how some of the cards look like. You have the 12 ports, RJ45, 12 ports with RJ21, 24 ports, and here is a modular port where you put the modular ports. Here's how the modules look like. Here's the 10-base 2, fiber, the AUI, the station side, and the repeater side, and the 10-base T. And this is how these repeater cards are configured into the system. As I mentioned before, we have up to 8 10-base segments, and these 8 segments are divided into two types of buses. So we have, I write it here, we have 8 10-base segments. 4, we call it ESB, which is an Ethernet synchronous bus. And there is 4 EB2, which stands for Ethernet base 2. So this card, this segment, this type of bus is used to tie several repeater cards, so they can behave like one repeater. And the 10-base 2 and the EB2 is functioning like a 10-base 2 segment. and we use it to tie the repeater card into the switching machine. So for example, you see here that these two cards acting like one repeater card. The other one is acting like another repeater card because they are connected to another ESB. And from there, they are connected to EB2 to another switching card. Okay? Another card is a LC372. It's a 100 base distribution card. It has up to 12 ports of 100 base Ethernet. PSA-100 is of course only 100 because it's a repeater. It also has a modular port, and on the modular port you can either put 100 base SX, or you can put a module that has two-port switching. One port is going into the repeater and one is going externally to the network. In this way you can contact with another distance remote station. Otherwise, you know that the repeater is limited in its diameter. You can go up to 400 meters, and this is of course a limitation. So with this switch you go over this limitation. I will just erase this. These are the modules that I just mentioned. The first one is dual port 100 base FX, and the other one is two models of this two-port switching. One with 100 base FX, and the other one is with 10100 base TX. This is how we tie them into the system. We use the Ethernet buses to connect also the fast Ethernet distribution card between the cells in order to make a bigger repeater. So you see it here. And then you can take one of the ports into the system and tie it into the switching card. We also have token ring repeater cards. We have also several options. Here you have 12 ports of STP or 12 ports of UTP. We also have another version of the same card with 16 ports. Another version where we have two trunks, R in or out. And another version of the modules that can go into this card. There is an optional module on this card. You can also select between 4 and 16 megabit per second for all of them. Automatic backup. It makes its own, it regenerates the signals again. So this is what we call the signal processing.